This presentation is about interoperability, open communication protocols, open standards, concepts that I believe all of us in this room are generally familiar with in different contexts, but I'm going to talk about it specifically in the EV charging ecosystem context. A big focus of open standards in this context is to future-proof assets. And so that's going to be one of the key points I hit on. But open standards and interoperability have a lot more benefits within the EV charging ecosystem. So I'm going to touch on those too. And this matters to you, to utilities, if you are thinking about program design, thinking about if you're involved in the actual procurement, installation, if you're thinking about the user experience of the drivers, it matters to all of that. And so the big picture is open communication protocols and standards support a smart EV charging ecosystem. They support a flexible ecosystem, and they support a resilient ecosystem for the drivers, for the site hosts, and for the utility. So this first slide is heavy on text, and I don't know if you can read it well in the back. I'm going to spend a lot of time just on this first slide because this is really the heart of the presentation. And so one way to start kind of thinking about interoperability in the EV charging context is to think of it in three buckets or dimensions. So the first one has to do with the actual physical plug, the charging port. I'm not going to spend a ton of time on that. The level 2 plug is standard. It's the Society of Automotive Engineers, SAE J1772. That is standard in the industry. In North America, there's a separate European version, but in North America, it's standard. DC fast charging, there have been two competing plugs. I saw on Chris's presentation, there was Chris included the maximum power levels of the two plugs. But the industry is largely coalesced around the CCS fast charging plug. It stands for Combined Charging System, which is basically the 1772 plug, the J1772 5-pin plug with two direct current pins underneath it. Every DC fast charging installation you're going to see today and in the future is going to have CCS connectors. Some may have a CHAdeMO plug as well, but I think in the not too distant future, we're going to see just entirely CCS combo plugs for the fast chargers. And that's obviously important from an interoperability standpoint for the driver because it enables any vehicle, Tesla notwithstanding, which requires an adapter, but any of the other vehicles to plug in to either 1772 or CCS. I'm going to move on from that. I'm happy to take questions afterwards, but the main focus of this presentation has to do with this part. So the second bucket, or second way to think about open standards and interoperability in this EV charging context has to do with transaction, the driver transaction. So I'm going to focus first on driver roaming. And so what I mean by that is if I have an account with Shell Recharge Solutions, formerly Green Lots, and I pull up to an SRS branded charging station, then I can just pull out my app and the QR code, press start. After I plug in, press start, and then I start the session. I already have my information. I already have my credit card entered into that account. If I pull up to a charging station that does not operate on the SRS network, what driver roaming means is if there's an agreement between the SRS network and this other network, I can still use my SRS app. I don't need half a dozen separate apps and accounts and my credit card info loaded into all of those. It wasn't too long ago that people were carrying around like separate RFID cards, half a dozen of those cards. It's moved more towards being able to do that with apps. But driver roaming is an agreement between the network operators on the back end to authenticate and authorize payment and start a charging session, even for a driver who is not a member of the network that operates that particular charging station. The communication protocol that governs driver roaming in the US is OCPI, Open Charge Point Interface. In the context of these protocols, Open Charge Point, we're not talking about the company, we're just using the more generic term. So OCPI is a protocol that a number of network providers in the US voluntarily got together and developed. It's not proprietary, there's no royalties involved, there's no transaction fee that's added or deducted when a driver pulls in and charges up on a different network. It's seamless and there's no additional fees. Last year, as an example, Greenlots at the time, we entered into agreements with ChargePoint, Flow, EV Connect, and so if you pull in, so that enables any one of a driver who's a member of any one of our networks to plug in at any one of the other networks and gives people access to like 60,000 plus charge ports across the US. Again, this is a voluntary industry-led communication protocol. Another aspect of the driver experience has to do with credit card payment. And this isn't really about communication protocol, but it's something that all of you should be keeping in mind if you're thinking about procuring charging stations. While most EV drivers use apps or RFID cards, membership cards, there are a number of drivers who still pull up and use credit cards. And so at least today, maybe not 5 years from now or 10 years from now, but at least today, most public programs, regulatory programs, federal money require some sort of physical credit card payment option, whether it's a swipe, whether it's you insert the chip, whether it's just a tap. But today, at least, the ability to accept credit card payments from the perspective of the company I work for is important, particularly when we think about equity and access and universal access to charging. Another aspect of the driver experience is plug and charge, which is what it sounds like, where you pull up to a charging station, you plug in your vehicle, and then it automatically senses the vehicle and commences the charging session. And I'll get to that more in a minute. So the charging port is one bucket of interoperability. Driver experience is another. And then this hardware software communication piece is really, when people talk about interoperability, this is a lot of times really what they're focusing on. And this is really critical for a number of reasons. And so the big communication protocol is OCPP, Open Charge Point Protocol. And that is the communication protocol, the common language between the hardware and the software. And so ABB is an example of one hardware provider that has embedded firmware in the chargers that support OCPP. Schneider Electric is another example. BTC Power, Tritium. These are all examples of leading hardware providers that engineer their devices to support OCPP. And then in terms of the software network is software engineered to communicate to those chargers by these communication protocols. So Shell Recharge Solutions is EV Connect, SemiConnect, a number of others. In terms of the subject or the title of this presentation, future-proofing, the most obvious and important way that OCPP matters to anyone who owns an asset is that it avoids stranded assets. So if you purchase a bunch of charging stations and you don't like the software network operator goes out of business or isn't providing good quality service, or wants to raise prices or whatever it is, you're not stuck with that software network operator. You have the ability to swap out a different software management system that communicates using OCPP. So particularly when we're talking about public dollars or co-op member dollars, using OCPP is an important way to safeguard those assets and to preserve those assets as in use. Related to OCPP, or I'd say building on top of OCPP, is OpenADR. I'm imagine everyone in this room is familiar with automated demand response. Many people are familiar with OpenADR, which is developed by the OpenADR Alliance. It's an open communication protocol to do demand response, not just in EV charging, in a number of other contexts, but OpenADR in the EV charging context allows utilities to implement demand response events through the OCPP protocol. So it's not direct to the charging station, it communicates via OCPP to the charging station. And again, OpenADR is not proprietary, it's royalty-free, it's developed by a transparent and collaborative industry and stakeholder group. ISO 15118 is a standard that's in place and is being revised by a more traditional standards making body. And it governs kind of a bunch of aspects around the EV charging ecosystem. There's the current version of the standard that's on the market today is ISO 15118-2. There is a revised version of the standard under development, -20, that we expect to be published later this year. It may still be a couple years after that before it's widely adopted. But some of the aspects of the EV charging ecosystem that are addressed or covered by 15118 include plug and charge, which I mentioned earlier. ISO 15118 is the most widely accepted standard that creates a uniform framework for plug and charge across the industry. Also bidirectional charging and also wireless charging. When it comes to 15118 and plug and charge, not every hardware charging station, not every software management platform today supports plug and charge. A number of them do. The Electrify America network does. When it comes to vehicles, the Ford Mach-E supports it, and others, but not everyone does. So when you're thinking about future-proofing your assets, if we expect ISO 15118 to become widely adopted and really the de facto standard across the industry, the critical thing is there's a 10-cent PCB, printed circuit board transceiver chip, that is necessary to enable this plug and charge functionality. And some charging stations include that already and others don't. And so from a future-proofing standpoint, even if you're thinking, okay, we don't need to implement this standard today, we don't need to have plug and charge today, if you are thinking about these assets being in use 5 years from now and meeting current demands 5 years from now, that's an important question to ask of the vendor or look on the spec sheet to say, is it ISO 15118 capable? Does it have this transceiver chip embedded in it? So let me pause here. That's a lot. Yes.
It was mentioned yesterday that ChargePoint not using open dialogue. Is this what was referred to? The ChargePoint was one of the only ones not really using open dialogue, or I misunderstand?
That's a good question. So ChargePoint, and I don't want to speak for ChargePoint. My understanding is that ChargePoint markets its devices as OCPP compatible. And that brings up a really important point because, and if there are others in this room who have experience and want to share their perspective, please feel free. But just because a charging station, the hardware device and the software platform are engineered to support OCPP does not mean that the provider enables network switching. And I can tell you just from my company's experience, we have had some jobs where a customer has asked us to rip and replace ChargePoint products, even though they, I believe, are engineered to support OCPP just because of difficulty of swapping out the software platform. Peter.
So when we did our bid for pilot, we did that, the network had to be with equipment interchangeable, right? With those open OCPP. Charge point says they have OCPP, but they will not let you hang any other equipment on their network. So they did not bid. I'll just leave it at that.
So if you can build a station essentially with OCPP compatibility, but not fully open to the OCPP network, is there any concern that that could go the opposite way where someone markets you a station that is on the OCPP network and then at some point takes away those capabilities from you?
That's a good question. I don't know the answer to that. Where a station is engineered to support OCPP and then they remove it. I've actually never gotten that question. So I need to think on it more. So about OCPP, OCPP was developed by, as I said, by the Open Charge Alliance, not the Open ADR Alliance, the Open Charge Alliance. Up until recently, the OCA had a self-testing process where a vendor would kind of download, I'm not super familiar with it, but would basically self-test and say we're compliant or compatible with. Within the last couple of years, OCA has established a true certification process with independent national testing laboratories. And so there is a third-party independent certification process available now for OCPP. And in America, the lab is the DEKRA lab, DEKRA, in Sterling, Virginia. And so one of the recommendations or encouragements that we generally make to policymakers and to folks who are designing programs, which relates to this whole discussion, is not just requiring on the spec sheet that a charger be OCPP compatible, but taking it a step further and requiring that the vendor demonstrate third-party certification and agree contractually to enable network swapping, as Peter mentioned. And that's those steps are the best steps you can take if you're involved in procuring this equipment and you truly want to make sure that you are not going to have a stranded asset 5 years from now. Right, moving on. So this is a graphic that basically represents what I've just shared with you. Hopefully it makes it simpler, not more confusing, but let me just walk through this visual representation. So here is the charger at the center. This is the software management system. So when you have a smart charger, you have firmware embedded in it, but you manage it using a cloud-based platform. So Chelsea Charge Solutions, our network management system is called Sky, S-K-Y. It's cloud-based. And so if you own the charging stations and you want to set pricing or set access or anything like that, you do it in the cloud. The cloud communicates to the charging station via OCPP, what we've just been talking about, the hardware-software communication. This is the utility. This is your utility. So you want to implement a demand response event. So you use through OpenADR, you implement it through the cloud-based network management system, which communicates to the charging station via OCPP. For driver roaming, remember that protocol is OCPI. And so that's what this represents. This could be Chelsea Charge Solutions. This could be Flow. So the charging station, the driver pulls up, plugs in the charging station. I'm not a member of that particular network. It's okay. The software networks communicate on the back end and the driver can still charge. So the driver has a nice seamless experience. And then when you're talking about the vehicle plugging in and communicating to the charger, that's where you implicate plug and charge and specifically the ISO 15118 protocol standard. Awesome, right? Like the very last presentation after a day and a half before lunch. All right. I'm going to move on.
Can I add something,
Yes.
Josh?
Yes.
So the open ADR signal that these platforms can take in, you can
Yeah. also,
if you don't have a DERMS platform, an ADMS system that can produce that signal, you can do it manually through the software platform. Go into load control. If you get a signal from UGNT,
I've got a question yesterday about a utility that uses the OATI platform, right? OATI, which is compliant with OpenADR. So to Robbie's point, yes, there's a lot of communication and validation of these different protocols to work together in different systems. All right, I'm going to just pause. This summarizes some of the key points I've made. I do want to add one more point about OCPP. And it has to do with competition and innovation within the charging industry. So one of the neat things we're seeing in the EV charging industry is a lot of entrepreneurial startups are coming in and figuring out how they can add value to this ecosystem. There are companies like LeafGrid and EV Energy and others who don't manufacture the charger, they don't do the software management platform, but they see a way, whether it's aggregating some of the vehicles, whether it's kind of compiling data and helping utilities like really sift through and get to the core of what actually matters for this data. And that is another area where OCPP is necessary because it enables these smaller startups that will get venture capital and will like become multi-million-dollar companies 5 years from now, but enables them to get into the industry without having to pay royalties because it's not proprietary communication and come to you as a utility and say, hey, I can add some value here because I can play in this space and I can communicate. So it's another example of how open standards is good for the industry. It supports competition, supports continued competition even after the time that you purchase the charger, because you can swap out the network. So if there's additional developments in networks and they offer different functionalities, you can swap it out after a couple of years. The final key point I want to make when it comes to OCPP in particular, from your perspective as someone in a utility, if you're going to be responsible in any way for actually rolling out an EV charging program, has to do with the testing and validation of the communications. And so put simply, if you are looking at a bunch of spec sheets from different companies, looking at different models, and you see spec sheets that say OCPP compatible, and you're considering a software management platform like Sky or like other companies that communicate via OCPP, that is not enough to ensure that the devices actually communicate seamlessly. And so if you want headaches, the way to get headaches is to just, pick different models that have not necessarily been tested or validated. So yes, the critical piece is the hardware needs to be engineered and the firmware to support OCPP. But beyond that, it needs to be tested and validated to actually work in the field on a particular software management system. So Shell Recharge Solutions, we have an innovation lab in LA where before we offer, and we're not the only type of company that does this, but this is as an example, before we offer any manufacturer and any model, we get one of the units in our lab, and we run it through a 3-day battery of tests to simulate all sorts of real world scenarios, demand response events, fault events, all sorts of things. And almost always it requires going back to the manufacturer and requiring some adjustments. And then only then, once it, passes all of these tests with 100%, do we then offer it to our customers. So for you, if you're involved in procurement or you're talking to vendors and you have a software network in mind, just a simple question is, has this unit been validated to work on this particular network? And you'll save yourselves headaches if you ask that question in advance. So to wrap up, some key recommendations when it comes to public funds or member-supported co-op funds. We encourage requiring not only OCPP compliance or compatibility, but actually this third-party certification. We encourage support for open ADR. We encourage being hardware ready, meaning at least have that PCB chip to support ISO 15118, which I do expect will become a more widely adopted expectation over the next few years. And to Peter's point, require in whatever contract you ultimately sign that the hardware provider and software provider require them to enable switching networks, not just have OCPP compatible devices. All right, any questions? Any other perspective folks want?